Multiplication of monomials. The fundamental idea when multiplying two monomials is simply using your multiplying like basis property of exponents. For example, suppose we wish to multiply 7x cubed times 6x squared. We multiply the numbers to give us 6 times 7 being 42. Then using the multiplying like basis property, we add the exponents. X cubed times x squared gives us x to the 3 plus 2 power, which ends up giving us as a final answer 42x to the 5th. When multiplying a polynomial by a monomial, the fundamental idea is using the distributive property, which says for all real numbers a, b, and c, a times the quantity b plus c is equal to a times b plus a times c. For example, suppose we wish to multiply 3x squared times the quantity 3x cubed minus 3x plus 8. Distributing the 3x squared, we have 3x squared times 5x cubed minus 3x squared times 3x plus 3x squared times 8. Multiplying the numbers and using our multiplying like basis property of exponents, we have 15x to the 5th minus 9x cubed plus 24x squared. When multiplying two polynomials, the idea is exactly the same. We use the distributive property, but we will use it more than one time. Suppose we want to multiply the quantity 3x or 7x plus 3 times the quantity 2x plus 5. Treating the 7x plus 3 as one entity, just because it's in parentheses, we distribute to give us the quantity 7x plus 3 times 2x and the quantity 7x plus 3 times 5. Now we distribute a second time. The 2x distributes across the parentheses for the 7x plus 3. The 5 distributes across the parentheses for the 7x plus 3 to give us 7x times 2x plus 3 times 2x. In the second distribution, we have 7x times 5 plus 3 times 5. Multiplying this gives us 14x squared plus 6x plus 35x plus 15. Now combining like terms gives us a final answer of 14x squared plus 41x plus 15. Now we want to multiply x minus 2 times the quantity 4x squared plus 9x minus 2. Again, we start out using the distributive property. We distribute the quantity x minus 2 to all three terms in the second polynomial to give us x minus 2 times 4x squared plus x minus 2 times 9x minus x minus 2 times 2. Then we distribute a second time in each one of the second set of parentheses. So we have 4x squared times x, 4x squared times 2, 9x times x, and 9x times 2. Finally, 2x plus 2 times 2. Now we combine like terms. We have a minus 8x squared plus 9x squared minus 18x minus 2x gives us, for a final answer, 4x cubed plus x squared minus 20x plus 4. Finally, we come to multiplying using special products. Special products are multiplication formulas which arise so often that we use them as shortcuts. It's not absolutely necessary to use them, but they are very good practice and may save you time. The first formula is the perfect squares formula. When you're multiplying the quantity a plus b squared, that ends up being a squared plus 2 times ab plus b squared. When we multiply a minus b quantity squared, we have a squared minus 2ab plus b squared. Finally, the difference of squares formula, if we wish to multiply the quantity a minus b times the quantity a plus b, that is nothing more than a squared minus b squared. Suppose we want to multiply 2x minus 3 times 2x plus 3. This corresponds to a difference of squares formula with a equal to 2x and b equal to 3. Following the difference of squares formula, every place that we have an a, we replace with 2x. Every place with a b, we replace with 3 to end up giving us 4x squared minus 9. Once again, using the special products, suppose we wish to multiply the quantity 2x minus 3 squared. Once again, this is a perfect squares formula with a being 2x and b being 3. In the perfect squares formula, a minus b squared, we replace the a with 2x, the b with 3, every place in the formula to end up giving us a final answer of 4x squared minus 12x plus 9.